Hello everyone, welcome to Kanai's AI Lab, where we make AI concept simple and practical. Today we will be implementing linear regression in Python using Jupyter Notebook as our IDE. I will take you through both procedural and object-oriented programming approaches using Scikit-Learn to showcase how can we simplify and improve our workflow. I provided the link to the code and dataset in the comment section, so feel free to follow along. Let's get started. Before we jump into the code, let us understand what is a linear regression. A linear regression is a statistical method used to model the relationship between a dependent variable y and an independent variable x using the equation y is equal to mx plus b or y is equal to mx plus c, where x is the independent variable, y is the dependent variable, and m is the slope of the line determine how y changes with x, and b is the intercept, which is the value of y when x is equal to 0. To understand what is our x and y in this particular problem, let us read the data. I'm importing the library called pandas for data manipulation and also loading the pandas pd.read underscore csv to read the data set. Our data frame, our data name is hsc underscore data, which is in the csv format. Also, I am going to read this particular data in 3 steps. Let us execute this line of code. You can see the result where we have 2 columns. One is severity score, another is hospital stay underscore days. So our x is now severity score and y is the predicted hospital stay. So what is our aim? We are trying to find a line that best fits out to our data points so that we can predict hospital stay based on severity scores. So this is about the understanding of data set and the problem. So this data set contains severity scores and corresponding to hospital stay days for different patients. And our goal is to predict hospital stay based upon severity score. Now, moving to the step number 1, we are going to compute linear regression or prediction of y without any library. So let us see the equation for finding the m and b. M is nothing but the slope and b is nothing but the intercept, which we already learned in our schooling days. So we are going to find out what is our x. We first x and y values from the data set and store them into the list. Now after that, we are going to find the number of elements, that is length of x, which is 100 in this case. And we are finding sum underscore x, which is the sum of x values, sum underscore y, which is sum of y values, sum underscore xy, which is the sum of x and y product values, and sum underscore x square, which is the sum of x square values. Using these value, we are going to compute the slope value, determine the relationship between x and y, and also we are going to find out what is our b, the starting point of the regression line. So let me execute this entire step. Yeah, we have computed our M and B. From the M and B, let's predict the hospital stay for a patient with a severity score of 7.5, which is the new value which we are passing to the equation. So if my x is 7.5, the computing equation y is equal to m into 7.5 plus b. I'm going to print the result. So you can see here the predicted hospital stay is 14.66 in days. So this works, but manually calculating these values every time is not efficient. So what if we have thousands of data records? The manual approach to the linear regression is always time consuming. It also prone to errors and inefficient for large data sets. So making it impractical for real world problems. So that's why where Scikit-Learn simplify our work. Scikit-Learn is the machine learning library which is available to use for free. So instead of manual calculation, we can use Scikit-Learn built-in function to fit the model and predict values with just a few lines of code. So here is the code for us. So you can see that I'm importing the linear regression from the Scikit-Learn library, which in short called as Scikit-Learn. There is a method called linear underscore model. So we are importing linear regression. Also, we are importing NumPy, which is giving an alias of NP, which is for numerical computation. So we are taking our X and Y from the data frame and reshaping into 2D array. We know that Scikit-Learn expect X to be a 2D array, so we reshape it. Then create the model object. What is the model object? You can see a model is equal to linear regression. After that, we are initialize the linear regression model using model is equal to linear underscore regression. So we are going to train the model dot fit of X comma Y. This finds the best fit line of our data. So once the model fit or machine learning or model training, we will be getting our parameters. In this case, the parameters are M and B. So model.fit will generate M and B by default. Also, basically, it's the training of the machine learning model or learning of the model. So let us execute this. After model prediction, after model fitting, we are going to use another method called predict, which is for predicting the Y value for the new given X value. So I am passing a value of 7.5 once again, and I want the result for prediction of Y corresponds to the X value of 7.5. So let me execute. You can see here, this is executing. The predicted hospital stay is again 14.66 days. As you can see, Scikit-Learn does all the heavy lifting for us, making it faster and easier to implement linear regression. So we are going to the concept of OOP, that is object-oriented programming, which is a paradigm that organizes codes into reusable objects and classes. Using the OOP principles, in Scikit-Learn improves the code reusability, code maintainability, and scalability. Basically, it's making it easy to handle complex machine learning tasks efficiently. Now, let's understand how object-oriented programming concepts are applied to Scikit-Learn linear regression model. The class. In Scikit-Learn, linear regression is a predefined class. This class provides a structured way to implement regression models without manually computing the parameters. Object. When we create an instance of this class using model is equal to linear regression, it acts as an object. This object allows us to access built-in functionalities for training and predicting the values. Next, we have method. The linear regression class comes with predefined methods. For example, the fit method used to train the model and the predict method used to make predictions. This method belongs to the class and are applied to the objects that we created. We have another concept called encapsulation. In OOP, the encapsulation helps protect data by restricting direct access. In simple, in linear regression, the model learned parameters such as the slope and intercept, M and B, are stored inside the object, ensuring data security and controlled access. The inheritance is nothing but the linear regression class is not built from the scratch. It inherits method from the base estimator class. In simple, this means it automatically gets functionality from Scikit-Learn, making it easy to extend and reuse. Whereas polymorphism, which is another very important concept, which allows different models to use same method, but in different ways. For example, both linear and logistic regression have fit method. Not only logistic regression, every ML model has the fit method. But they use it in differently and their computation inside is also very different. This flexibility makes Scikit-Learn models more efficient and adaptable. So, in summary, by using OOP principle, we make our code more reusable, more scalable, more maintainable. This approach makes essential for working with machine learning models efficiently. So that's it for today's session on linear regression using Python. We covered both procedural and OOP approaches, and so why Scikit-Learn or Sklearn makes things very easier. So you can drop your question in the comments and I will be very happy to answer them. See you in the next AI lab session. Thank you once again for watching the video.